Hello guys, welcome. It's your boy Clover.
I kicked off my laser engraving journey some weeks ago and had the false impression that the print file taken as input was dependent on my laser engraver. In reality, it depends on the program you are using to run the engraver. In this case, the open source LaserGRBL. Imagine my surprise when after reading this in the manual, I could not upload my DXF file to get out this test fan project. Turns out LaserGRBL takes certain files and with others, well, you'd have to do a bit of conversion. Let me explain. One of my motivating factors for getting a laser engraving machine was because I considered myself skilled enough to be able to design on 3D and 2D CAD software, whatever I could possibly imagine, and cut it out, not just limiting myself to already existing models available online. So far, I have engraved on plywood, aluminum, acrylic and some other plastic. Also cut mostly plywood. I have used a wide range of forms and shapes and played with the LaserGRBL setup a lot. It's really the best way to learn with this one. I use two main types of 2D output files, PNG when I design on Canva or a similar graphic design program, and DXF if I use Fusion 360, SolidWorks, AutoCAD or any other CAD software which outputs DXF. And for those wondering why I don't just output these CAD softwares as a PNG, here's why. After exporting as PNG, most CAD softwares will export it like this, and you already know it will require you losing the background somehow and just messing up the forms and ending up with this mess to work with. Avoid that part. Now let's see how to upload custom files from graphic design software. Taking Canva for example, I designed this simple sign that says Dr. Rainbow with her picture, this little heart and a stethoscope to be engraved on acrylic. Exported from Canva as a PNG file and uploaded to LaserGRBL. Tweaked the settings to my liking and keyed in the right dimensions. The offset is there for the reason I gave in the unboxing video. If you don't have this issue, you can just set it to 0. The process ran for 13 minutes. It was my first time engraving acrylic. And what I said in my previous video about proper ventilation could not be emphasized any better than with the fumes that were produced with this one. It smells terrible. Make sure you have proper ventilation and stay about 2 meters away from the engraver when working with acrylic, or use a protective face mask if, like me, you don't have a vacuum system. A quick Google search debunked my fears of it being very toxic, but that smell though. It turned out pretty clean. So summarily, from Canva or any other graphic design software of your choice, you can export a PNG to LaserGRBL, which is going to send G codes to the engraver, and you're going to have your required output. For designs which require some level of detail and sizing for fitting with other components, I use a CAD software, either 3D or 2D. I was going to test this with a reverse engineered fan model of this mini fan, but made of wood and other local material I can lay my hands on. It is made up of a fan cover, which in this model has a ring for holding a light strip. It is a single piece in the actual product, but I had to separate it and glue them together for the wooden prototype. As already mentioned, LaserGRBL does not take DXF files, so the alternative is to upload the DXF file into a free vector graphic editor like Inscape. Yes, you can use Adobe Illustrator as well, but Inscape is free. Once in Inscape, you just simply centralize the object and export as a PNG. Then import your new clean looking PNG to LaserGRBL and tweak the settings for cutting, then kick it off. Each of these require 2 passes, with each pass running up to 18 minutes. So these two require a total of little over an hour to properly cut. Make sure to properly set the engraver head, as you can either just be scratching or burning the wood if you are too close or too high, as you can see here. It turned out mostly good. Some cuts weren't leaving easily, probably because the board itself isn't flat enough and my work table lacks machining clamps to hold the panel flat on the table. The middle section required a volume of wood I wasn't even willing to consider, not with my 5.5 watt laser engraver at least. I just used styrofoam instead. Not very fancy, but it did the job. The back is exactly like the front, but for this semicircular piece to attach the base. The blades followed a similar process, and I think they came out pretty good. For the base, I just cut out some wood, which I had at home with my jigsaw, and put everything together. By the way, this is a 3V fan and a 3V light strip. I'll probably discuss the entire making of this in another video. It turned out fine for a test. It just reassured me of the many creative possibilities with a laser engraver. So to summarize, from the CAD software, you can export as a DXF file, which you can open in Inscape, convert to a PNG or any other format accepted by LaserGRBL, then import to LaserGRBL and you'd have your output. So that's it for this video. I keep having only positive things to say about my laser engraving journey so far. The limit is really how imaginative you can be with this one. Thank you.
Anyways, it's been your boy Clover, guys. Like and subscribe for more. See you all in the next one. Thank you.